Hello and welcome to everyone who's joined us to the GSE Virtual Conference New Technology session. This is session AN, and please remember to do your feedback at the end. So this session is SSO and the mainframe. Are you ready to leverage it? Oh, we've got more people joining. So a couple of items of housekeeping before I introduce our speakers. Please remain on mute. You're not able to unmute yourself at the moment, but towards the end of the session, we will unmute you, but please only unmute yourself if you're speaking. It's nice to remain off camera as well. Also, any questions you have and greetings telling us where you're from, please put them in the chat and hopefully they'll be answered throughout the presentation. If not, we will be able to get to them at the end. So as I say, this is session AN and we do appreciate your feedback after the session. You can get to it by clicking through the BYOA link and it's in the box. That's probably the easiest way to get to it. So SSO and the mainframe, are you ready to leverage it? There's an increasing need for tools, processes, and architecture that allow modern mainframes to move fast without sacrificing quality. And APIs are the key to securing quick and secure access to data on the platform. Today, we're going to learn how the Zoe API mediation layer is powering modern workflows with a secure single sign-on experience from the network to the mainframe across sysplexes and security domains. Our speakers today are Elliot Jolly and Jakub Balar. So Elliot is a product manager at Broadcom Mainframe R&D Center in Prague, focused on modernizing the way we work with the mainframe. Over the years, Elliot has been heavily invested in improving the mainframe experience for ZOS software. More recently, he has been a key contributor to the Linux Foundation Zoe open source framework. Zoe provides solutions that allow development and operations team to securely manage, control, script, and develop on the mainframe like any other cloud platform, and is the first open source project based on ZOS. Jakub is the product owner for our API mediation layer at Broadcom. He's a Zoe chair, a rising IBM champion, and a mainframe star. So without further ado, over to you guys.
Thank you for the introduction. Hello, everybody. Welcome to our session. So today, so maybe if we just go back to the agenda. Yeah, good. Thank you. So just to kind of introduce our session today and give you a flavor for what's coming up. So generally speaking, you know, we know that APIs for the mainframe, they're key to securing quick and secure access to data on the platform. So we're going to talk a little bit about the role APIs play. Talk a little bit about the role of the Zoe API mediation layer as an enabler for securely and efficiently managing these mainframe APIs. But specifically, that the focus of the session today will be on how the mediation layer offers a single sign-on experience into your REST services from your very first login of the day, right? As you log into your network. Okay, let's go on. So a little bit of context before we get into the details. So we know that the mainframe has, you know, a long established authentication authorization procedure that continues to provide you know, a high level of security, and you know, that's one of the ways that the platform is one of the things that the platform is renowned for. So we're seeing that, you know, multi-factor authentication, for example, that's increasingly a part of security policy. You know, we know that there is a utility called SAF that enables programs to use system authorization services to control access to the resources on the mainframe. And then we have, you know, ESMs or, you know, external security managers that process these authorization requests. So, you know, we've got this kind of well-established security framework for the mainframe, and this is just, you know, just very, very high level, obviously. So if we go on to the next slide. So that said, you know, if we think about single sign-on, actually, you know, in a sense, if you think about it, the mainframe has always had a form of single sign-on. So on the platform, what we have is we have different roles who have different levels of access to resources on the mainframe. So this prevents a scenario where any one individual can have uncontrolled access to mainframe system. Now, the advent of APIs over the years has somewhat complicated this single sign-on landscape because often further authentication was necessary. Okay, next slide. But what about single sign-on? We've talked about single sign-on once you're authenticated on the platform, but what about single sign-on from your network to the mainframe itself? So, as this slide shows, today, most organizations have what we call identity providers. So you might be familiar with Okta or Microsoft Active Directory, which they recently rebranded to Microsoft Entra. So those are identity providers, and most organizations have these kind of identity providers that streamline authentication into the tools and utilities that someone uses for their daily work. So if you're like me, you'll come into work, you'll sign in via whatever identity provider you use, and then you'll have a dashboard of applications that you can then access. You're already authenticated through your through the identity provider that you use. But here's the catch on this. The mainframe over the years wasn't part of this landscape. So it means that if you're a mainframe engineer, you need to additionally authenticate into the mainframe. So next slide, please. So the mainframe is missing out on those benefits, on those single sign-in benefits, which generally, for you as a person that works on the platform, it slows you down. It slows your workflow in a sense. So there's multiple sign-ins are needed into your network and then into the mainframe. There's room for human error. You end up getting locked out of your mainframe account if you're not quite sure about what your credentials are. A single sign-on would actually reduce help desk calls, actually, because according to Gartner, something like up to 50% of IT help desk calls are often related to forgotten passwords. It's less secure. So without single sign-on, you're depending on a sign-in, like a manual entry from your mainframe engineer. Single sign-on would help prevent unsafe password storage habits. So writing your password down somewhere so that you actually don't forget it. And then finally, and I think this is really important here as we sort of think about modernizing the mainframe. It reinforces perception of the mainframe as being behind the times, as it reinforces the mainframe as a silo, specifically towards existing but also upcoming new generation of engineers. So really, our goal should be that the mainframe should be just like any other hybrid cloud platform, right? That's a goal of the Linux Foundation's open mainframe project, of which Zoe is part, and it's a goal today for many of us that work on the platform. Mainframe should be just like any other hybrid cloud platform. So if you're a mainframe engineer, you just want to log in once, via your identity provider. I mentioned Okta, Microsoft Entra, and you want to be recognized by mainframe security under your mainframe identity. You also, that's an authentication perspective, but from an authorization perspective, you also want to be able to, once you're logged in, you want to be able to access all the mainframe services that are protected by SAF that we mentioned earlier, to which you're entitled. again, using just your network identity, which is mapped to your mainframe identity. So not just that, we shouldn't, I feel like we shouldn't just stop there in terms of that kind of network through to mainframe authentication authorization. We shouldn't just stop there. We want to apply, I've written here, apply identity federation to a mainframe context. So what I mean by that is that as a mainframe user, you want to access the data to which you're entitled across sysplex. Right? You don't want to have to, once you're into the mainframe, you don't want to have to then re-enter your credentials as you move across your sysplexes. Because at the end of the day, this is going to lead to a kind of a poor user experience for you. Okay, so let's move on. That's generally the context. Now we're going to talk a little bit about some of the, how we're focused on that problem at Zoe, and a little bit about the mediation layer. So we've been looking at this problem within the Zoe community, and specifically the mediation layer squad, because that's where the functionality has gone into the mediation layer to try and sort of address those that SSO need that I talked about earlier. So our focus as a mediation layer squad, the focus of the component itself is to offer simplified, secure access to ZOS system resources via REST services. So a single sign-on experience absolutely fits into that paradigm. So there's two things that we've introduced here that Jakob is going to talk about in some detail that are relevant here. So the first bullet point there is, we've introduced OIDC. So what that means is OIDC is essentially a protocol that we're utilizing in the mediation layer, and it means that there's no need for an additional login. So a mediation layer client application can verify the identity of a user by utilizing the existing authentication session from the identity provider, such as Okta or Microsoft Entra. Now, as I said earlier, we recognized that this identity had to be portable across sysplexes. So that's where that second bullet point comes in over here. So Zoe supports the management of multiple sysplexes, and by introducing what we're calling multi-tenancy support alongside the support for OIDC, it means it's possible to properly route and authenticate users across different sysplexes as well. Okay, I think the next slide is about the mediation layer. So Jakob, I'll hand over to you at this. Oh no, one more from me, I think, here before I hand over to Jakob. So this slide is an attempt to better illustrate the enhancements that I just talked about that are going into the mediation layer. So here we can see two people, Ashton, who's a mainframe operator, and Jane as a kind of a subject matter expert, a mainframe engineer. So what's happening here is that there's been an event which is recorded by Ashton's monitoring solution. So it's immediately picked up by him. Sometimes he can solve it if it's fairly trivial, depending on his level of experience. But on this occasion, he needs a subject matter expert, and this is where Jane comes in to investigate further. So he shares the event details with her as part of the newly opened case ticket. Jane is able to click on the event link in the case to see the details, and she begins troubleshooting. She has an active Okta session. It could be Microsoft Entra, some other provider, let's say Okta. So she has an active Okta session. So she's taken directly to the event in the monitoring solution without needing to authenticate. Now, her troubleshooting requires her to access multiple sysplex in their cross-sysplex environment. She has the necessary privileges and she's able to seamlessly access the data without having to authenticate at each sysplex boundary. So, the outcome is that she can quickly find the issue, she updates the case with the necessary data, and then Ashton is able to resolve the event. So I think this is a really nice illustration about how, the enhancements we talked about earlier just kind of in this particular case, simplified the resolution of a particular issue. Okay, now I think it's over to Jakub for a bit more on the mediation layer.
API mediation layer itself is part of the solution that we are trying to provide to help solve the problems that we've created ourselves. It's a set of services that is running on the mainframe that is kind of like an entry barrier or gateway, which is even name of one of the services, to all the other APIs that are, or the other infrastructure APIs that are living on the mainframe. And it allows them to participate in different ways in the single sign-on. In the coming slides, I will show you first how you can leverage the single sign-on from the client-side perspectives, e.g., what are the options you have for the authentication. And then if you have a service that would like to participate in the SSO, what are the ways how to participate? First, what are the options that you have from the client side to authenticate? You can use the JWT tokens. It's a typical method that's considered relatively safe for access for a short time span, e.g. few hours. Well, security experts will tell you a few minutes. UX experts will tell you 8 hours. It's up to you to discuss. Usually they are actually used for 8 hours. Personal access tokens is a type of tokens that those of you that are using GitHub know quite well. It's a scoped tokens that are limited to some extent and that are longer living. OIDC was already mentioned by Elliot a lot, and this is the integration with the external identity providers such as Okta, Entra, Azure Active Directory, Keycloak, and others. And the last one that's more for the service-to-service communication are the client certificates, where you can use a client certificate for your client machine or a tool such as Jenkins to authenticate against API mediation layer. So let's go into more details for the JWT tokens. JWT tokens or JWT token is a token you need to first get from us. To do that, you need to authenticate using your mainframe credentials against the out/login. Either you can use the REST endpoint that's available on the API mediation layer, or you can also authenticate in your browser from either API catalog or the Zoe virtual desktop. The token contains quite some amount of information that you can query from the API mediation layer. It's encrypted, but it's possible to decrypt it if you are interested in this information. The API mediation layer provides the keys necessary to do the encryption. One of the options and one of the functionality that is used for this potentially is for accessing the ZOSMF through the API mediation layer. The ZOSMF is onboarded to the API mediation layer in a way to participate in the SSO. So you can use all the mechanisms that I'm talking about also to access the ZOSMF. This is an example how you would access a different service. So throughout all the calls that I presented, the IBM ZOSMF on the previous slide and the one to the Broadcom extension to the API mediation layer, you can see that the zoe.gateway.net is the stable part of the URL and the port. And then the only thing that changes is the service ID that's just behind. So from the external perspective, you are accessing the same service on the same port. You are just changing the specific URLs that you are going, or specific parts of the URLs that you are going to. That makes it easier to manage and work with the APIs. The next type of the tokens is the personal access token. Personal access token, to make things a bit more confusing, is also JSON Web Token, because JSON Web Token is type of way to store information. But the important difference here is that this token is intended for a long time usage. For example, if you want to be able to access a specific service for 90 days or maybe even a few years, the personal access token does give you this option. By default, the configuration allows creation of the tokens with the validity of up to 90 days, but it's a configuration on the API mediation layer front, so you can change it if you want. There is no limitation on up. The personal access tokens has few other benefits compared to JWT tokens. The main one is the authorization one. When you are creating the personal access token, you are enumerating specific services that you can actually access with this token. That means that if you create a token that can be used against the OSMF, you won't be able to use it against OpsMVS, against RSC API, or any other service. The other one is that we provide the management for these tokens. So you can revoke a specific token as the user. You can revoke all of your tokens as the user. And as an administrator, you can also revoke all the tokens for the specific service or all the tokens for a specific user if you feel that there is something problematic going on in your infrastructure. The usage of the token is very similar as for the JWT. You are providing the token either in the header via the bearer header, or you are providing the token within a cookie. There is the API-ML authentication cookie. This works for both of these types of tokens. And then you are accessing the same IBM's OSMF API or Broadcom OpsMVS or other extensions from other providers like Phoenix or Segas. And here again, we see that it looks the same for the OpsMVS. Sorry. The next type of token that you can use when you are authenticating against the API mediation layer and therefore the services is the OIDC. Specifically, we are talking about OIDC access token because OIDC does provide multiple tokens and we are working with the OIDC access token. That means that first you need to validate yourself against some OIDC research server that will provide this token for you. And then this token is used by the API or used to authenticate against the API mediation layer. And the API mediation layer validates with the server providing the token whether it's valid and correct. And then after all, that also validates whether there is any user that's linked to this token and to the information provided within it. And if there is none, then you are not authenticated. If there is a specific user, it is authenticated. The good part about this is that for one mainframe user, you can have multiple external identities. So for example, if you want to, you can create a service user on the mainframe that will be accessed by 5, 10 identities outside of mainframe using their OIDC credentials. For example, if you have a high churn of L1 engineers, this may save you some time. And now a bit about when you want to use the specific methods. So the first use case that we see often is the DevOps use case, where you have some amount of pipelines that are running usually somewhere in your infrastructure or even in cloud. You probably use some tools like Jenkins to orchestrate this type of pipelines. And then you use the Zoe CLI and direct the REST APIs to actually operate or do stuff on the mainframe. To support this use case, we usually tend to use one of the free authentication schemas. The JWT is used, but it's not the perfect one because you don't want to change your credentials or keep your credentials in the Jenkins store. So ideally, you want to either create personal access token for a specific pipeline. You can have a plenty of personal access tokens. So you may have a specific personal access token for every pipeline, which gives this pipeline access only to the services that are necessary to actually run the pipeline. Other than that, client certificates are often used in this case because this is, like I already said, service-to-service communication. There is no human involved per se. And usage of certificates is very secure in this case. The only problem is that management of certificates tends to be something the organizations are not very happy about. Well, I would say it's just terrible. But maybe it gets better at some point. Another use case is about I'm showing specifically exploring the APIs that are available within the API mediation layer. But the main or core of this use case is the fact that it's happening within the browser. So basically, you are accessing some UI in your browser, and this UI on your behalf authenticates you against the API mediation layer and the services that you are working with. For these scenarios, it's very typical to use the JWT tokens because usually you don't need them to last for a very long time. Or, and I would say it's probably even better, to use the OIDC token because then you can really participate fully in your distributed single sign-on where you just authenticate once to your Okta or Entra or any other external identity provider, and then you just live with the token that you receive from this provider as long as you are alive in your browser. The last use case is similar to the DevOps pipelines, but there is an user involved. So the difference between the shift-left data management and the previous use cases I was talking about is that in the first one, we were talking about the service-to-service communication. In the second one, we were talking about UIs. And in this case, we are talking about the direct access to the REST APIs, but by a specific person instead of automated pipelines that are happening somewhere in the background that may be scheduled, where there really doesn't have to be any person involved. In this case, we tend to recommend either of the approaches, and it's either client certificates because they are requirement. But honestly, I would just recommend to use the personal access tokens. It's easy to generate them, it's easy to store them, it's relatively safe compared to the other methods. It doesn't allow the person to do whatever they want on the mainframe. So this is definitely the most typical and the best case to use for using them. This is a similar one. Maybe just a bit about what does the shift-left operations mean in this scenario. It means that there used to be some operator that you need to ask to do some changes in, for example, in the workload scheduling, or maybe in the database changes. Instead of that, now there is either a new in-house service or there is some service from the extenders that does what you need, or at least to some extent. And then again, there is some specific person that instead of like asking the specific person, goes and directly issues a request. This request is processed, and then the results are consumed either by a specific person or maybe by an application that they wrote themselves for somebody else or for them own. In this case, you tend to use either client certificates, personal access tokens, or JAT tokens. The reasons are very similar to the previous scenarios. With this, we finished the client-side part. So this is what you do if you are accessing the API mediation layer and you just want to build something on top of the REST APIs or use the REST APIs for managing and processing the information about the mainframes. The second part is about how does it look like on the other side. E.g., I have a service and I want this service to participate in the single sign-on. What are my options? There are 4 options, and they are different than the options on the other side. This tends to confuse people a lot because they hear single sign-on and they hear JWT and SAF-IDT and client certificates and personal access tokens. And most of the people are then confused. What can I use? Where does it live? What does it have to do with what I'm trying to do? So this is the other part that's happening behind the scene, behind the API mediation layer. If you are just using the APIs, you don't care. If you are creating new services and want them to participate, you do care. There are 4 main ways to participate. JWT token, it's the same JWT token that the client is using. It has the same behavior. It's just directly used. The API mediation layer provides the APIs where you can validate this token, and even the library for Java that you can just directly integrate in your app to do the REST calls for you. The new type of tokens that was introduced recently to the ZOS is the self-identity tokens. I will be talking a bit more about them, but in general, they are also JSON Web Tokens. They are just specific to the mainframe and are intended to be used as kind of like a single sign-on token for mainframe. They are not much used yet. We will see whether they will actually succeed. Client certificates forwarding is a method how we can provide the information about the client certificates, because as I believe everybody knows, client certificates are happening, client certificate authentication is happening on the level in the TCP/IP stack where we as the API mediation layer can't reuse the same certificate. We don't have the information. So the only thing that we can do is to provide the information that are part of the certificates to the subsequent service. And then the least preferred way, which is the pass tickets. In case you have a service that supports basic authentication, then what we can do is to integrate with you via the pass tickets, e.g. the user gives us personal access token or client certificate or whatever. We validate that it's a correct user, and then we issue a pass ticket on behalf of this user to authenticate against your service. The reason why it's not really recommended is because there is far more configuration on the administration side, and people tends to mess it up, and then they are unhappy. Here, I'm showing a bit about how it's actually done. This is really simple for the services because as a service, you don't need to change anything as long as you support basic authentication, and more or less all the services do. But the sysadmins will not like you. The sysprocs may even hate you actually if you really go this route, because it requires them to change the settings within the ESM. We are providing the exact commands that you should write in the TSO or in the ISPF in our Zoe web documentation. But regardless of this, somehow for some people, it doesn't really work out that great. And we've solved the problem. We can help with this, but yeah, please don't do that. The second one is the JWT token. This is the easiest one from the administrator, because for the administrator or the sysproc or anyone, there's no change. They just don't do anything, and it works. The bad part is that you as the service provider need to do some work, because you need to accept the JWT token and validate with API mediation layer that it's actually correct. Like, you don't have to, but if you are a security aware person, you always should validate. You should be very careful with your trust. The SaaS client is the Java library that can help you with delivering this functionality. And the SAF-IDT is a recent addition to the ZOS workplace. It's necessary to enable it, so there is some configuration, but it's not happening for every service. Like, you enable it once and then it's available within this ESM domain. But yeah, we will see. Like, for now, we do support it, but we haven't seen anybody using it. So it's kind of like a future proofing. It may become a standard, it may become relevant, and at that point, we are just already there to help you use it if you are using it for other reasons. The answer for you is the JWT token if you can and are willing to change your code. And then let's move on a bit on the multi-tenancy and OIDC topic. We've already talked about it a bit with Elliot, but what does the multi-tenancy actually mean, and where do you actually use it? So first, maybe who is this for? I would say that ideal user for the multi-tenancy is a service provider. You have many different customers that are living within a separate sysplexes, and you want to manage all of them at once. What we did is we prepared the delivery and deployment scheme where you have the API mediation layer on each of these sysplexes for every customer. And then on top of that we are adding a gateway that's living either on the OS or off the OS that is managing all these environments. E.g., all those environments are registered there, and you can query the information about them if you have the proper rights. You will not need this deployment strategy unless you have a very complex environments with multiple ESM databases, with plenty of sysplexes. So if your use case is, I have one sysplex with one ESM database and 50 LPARs, this deployment scenario is not going to help you. Ignore it. How do you do this actually? We do document it in the Zoe docs. Generally, it means that you need to deploy the API gateway and the API mediation layer on every sysplex where you want this to work. On the right side, I am showing the actual production deployment with the HA setups for every sysplex. So you have a HA deployment of the central gateway that everybody is communicating with to get all the information and to access everything across all the sysplexes. And then you have the API/ML gateway deployed in the HA mode together with HA0SMF, for example, in each of the customers. And you are accessing their services directly through the central gateway after you figured out which services you want to access and where. What's important to mention here is that most probably some kind of operators will be the ones accessing it, or maybe your L2 staff, and not necessarily the staff of the specific customers. The staff of the specific customers is probably gonna access their sysplexes just directly through the API mediation layer living there. But for your stuff, you may need to integrate multiple different identities across those different customers. So for example, you will have some kind of L1 operator, let's name him Ashton. And Ashton for customer 1 would mean Ashton 01. But for customer 2, it would mean XX Ashton service provider. And for customer 3, it's gonna be JBKL23, just because. And you want this person to be able to log in consistently across all of these, and you don't want this person to need to remember all of the credentials for each of these mainframes. That's where the OIDC protocol comes into play. The OIDC protocol allows you to map the external identity, e.g. say the person that within our Okta is known as Ashton is the person that for customer 1 is Ashton 01, for customer 2 is XX Ashton 02, and for the customer 3 is JBKD23. And you do the mapping within the ESMs. And then when this Ashton authenticates against the central gateway and tries to access one of these customers, the API mediation layer on the specific sysplex understands this OIDC token and properly translates it to something that the service is living within this environment understands. Obviously, after it validates with the ESM living with the current customer, that it is the person that it should be and who it is actually, and provides this information to the services living in this system. The next part is about how do you configure all of this and how do you do it with limited amount of pain. I wanted to say painless, but from what we are seeing, painless is not the right word. So first, there are many ways to configure Zoe. You don't want to know or use most of them. There are few. So first, on the right side, you can see the theoretically guiding help and diagram that can guide you through the whole installation. It's just the installation configuration. The installation is easy. That's the part that nobody has an issue with. But within the configuration, you need to edit zoe.yaml file. Zoe.yaml file by default is more focused on the next generation, who is comfortable living within the YAML files and JSON files. But if you want to edit it in ISPF, it brings some specific issues, like the fact that the spaces are meaningful. And so the indentation for different sections need to be consistent, at least somewhat. But let's talk a bit about how we can simplify it a bit for the use case where you just want the API mediation layer and you want to benefit from the single sign-on and OIDC. Zoe server-side also contains virtual desktop that's used for solutions such as IBM DB2 Foundations. And in that case, you need to configure the full Zoe server-side, which brings some additional configuration. But if you are going after the use cases we presented throughout this presentation, you can disable all of the services other than the gateway, API catalog, caching service, and discovery service. So you can disable app servers, ESS, Explore.js, Explore MVS, Explore USS, and DIS. You should be using internal mapper, which is a way how we validate with the ESM whether the specific external identity is linked to a specific mainframe identity. We have two options. One is using ZSS and using the code there. Another one is a direct C library that's embedded within the API gateway itself. This configuration will remove lots of the logs and lots of the information because lots of the services won't be started and they are not necessarily for this use case. What you can also do is you can leverage the fact that API mediation or Zoe can read multiple YAML files together. So you can have the basic .yaml within the example zoe.yaml, and then add on top of that another that just overrides the functionalities and properties that you want to change. You also don't want Zoe to generate or do anything with certificates for you. So prepare your certificates upfront. You probably already have a certificate for ZOSMF. If that's the case, and you have a ZOSMF certificate within your keyring, just give Zoe access to this certificate and use it as well. As long as you are doing it on the same URL, it should work for you. And then you can limit lots of the installation. There is the ZWE command, which is a command line tool that runs in the USS that manages for Zoe the whole preparation and installation procedures. And the ZWE init in general has 7 steps. And if you are after this simplified version, you can ditch 4 of them. And the only 3 you actually need is the ZWE init MVS, security, and STC. MVS will prepare the data sets that are necessary. Security will give you either, so depends on whether you have the security privileges. If you have security privileges, it can directly submit the JCLs that creates the proper users and gives them the proper privileges to run API ML. Or if you don't, it's possible to run it with security dry run option, in which case it generates JCL that you can then provide to your security administrators to take a look and enjoy all of the great new users and new privileges that they will have in their system. And the ZW and the STC is creating the actual started tasks that are necessary for Zoe. And with this, I'm giving it back to Elliot.
Thanks, Jakub. So we've more or less reached the end. I just wanted to highlight just a couple of what we call mainframe technical exchanges that we're hosting at Broadcom. We've just had the one in Prague for the Europe region last week. We've got one in September in the US. I recognize that probably there won't be too many at this time of the morning, too many US folks tuned in. But if you're watching this as a recording, then yes, there will be an event in September in North America. So these are no cost events for Broadcom customers to come and sort of network and learn a bit more about our roadmaps across all our solutions. Okay, and then I think one more slide here with the session feedback. So Aileen, I'll probably hand over to you at this point.
Thanks a million, Jakub, or Elliot, and thanks to yourself and Jakub for a really interesting presentation. Are there any questions? Because the chat has been silent after we welcomed everybody. Nobody has put anything in the chat since. I had started getting questions, but as you went through the presentation, you answered all of my questions. So now I need to sit on it, process, and then come back with questions.
We are both of us, Jakob and I, are both on LinkedIn. So if you're on that network, you can always message us there. Otherwise, we are both at broadcom.com, our emails. So Elliot.Jally, Jakob.Balha at broadcom.com if you have any follow-up questions.
Yeah, it's also possible to catch us on the OMP Slack and the Z Systems Discord if these are the preferred methods of communication for you.
Excellent. Okay, so everybody, please remember to do the feedback. So you can use the QR code there. But if you use the QR code or you use the links there, they don't give you your delegate number. So you can find that from your registration at MyGSE. Or if you're signed into MyGSE and you go to the BYOA, you can click on it there and your number is automatically populated. So the next session is Empowering Legacy, Bridging the Gap with Mainframe Modernization. And that's going to be at 12 o'clock. So thank you very much, everybody. And with that, I suppose we'll close the call.
Thank you. Goodbye.